sine of 0 is? 0. Do you remember your hand trick?
Which one's the x and y?
Oh my. X comma y is cos theta comma sine theta, just alphabetical. Okay. Sine of pi over 6. 1/2. Do you guys remember your left hand trick? Okay. Sine of pi over 4. Root 2 over 2. Sine of pi over 3. How about root 3 over 2? Sine of pi over 2. 1. Cos of 0. 1, yes. Cos of pi over 6. Root 3 over 2. Cos of pi over 4. Root 2 over 2. 1/2. 0. Remember, the sign goes in the opposite as the other one. Okay, and then tan is what divided by what? Yeah, sine theta divided by cosine theta. So 0 divided by 1 is 0. What do we get here? Well, you can use your hand for this too, right? 1 over root 3. You might also see the rationalized version of that, which is root 3 over 3. What about tan of 45 or pi over 4? 1. Tan of pi over 3, root 3, and tan of pi over 2. Undefined. Okay. Okay. Here is the graph of sine x over x. Can anybody tell me what the limit is as x approaches 0? 1. Right here. When x comes from the left, when x comes to the right, it is intending, and it does actually go to 1. So this is an identity that you need to memorize, is the limit as x goes to 0 of sine x over x equals 1. And we found out, actually, there was a homework question that you needed to know that. How about this one? If it's the reciprocal, if you have x over sine x as x goes to 0, what is the intended thing here? It goes to 1 as well. By the way, if I actually do this algebraically, what do I get when I plug 0 in? What's sine of 0? 0. I get 0 over 0, right? So there's an actual, like if I was zoomed in close enough, there's actual hole right there. Okay, so there's an actual hole right there, and a hole right there. I shouldn't be doing it as a point. But anyways, so the limit as x goes to 0 as x over sine x equals 1 as well. So make sure you have that in your back pocket from now on. You have to know that. Okay? So the next thing that you're looking for is patterns. So what your goal is to create this sine h over h, where h can be anything that matches with the bottom. So if I were to plug 0 in the way it goes, 0 goes in here, 2 times 0 is 0, sine of 0 is 0, plus 7 times 0 is 0, 0 plus 0 is 0. I get 0 on top, and what do I get in the bottom? 0. So I cannot do anything. I have to do something else. Investigate. Well, no, this is not necessarily investigation. Usually we go into factoring or conjugates. But when it has trig, it more involves trig identities, like the one you just found, sine x over x, or some of the trig identities that you use in grade 12 pre-calc. So we can split up the fraction. So the limit as x goes to 0 of sine of 2x over 3x plus the limit as x goes to 0 of 7x over 3x. Does everybody understand that's the same thing? All I'm doing is using the limit property as addition gets separated, and then the fraction property back in the day that we can separate a fraction like that, right? So right now it looks like it might be 0 over 0. However, what's beautiful about this right here the x's can cancel, right? And so what would the limit as x goes to 0 of 7 over 3 be? 7 over 3. This is a mess. If I put 0 in there and I put 0 in there, what do I get? 0 over 0. So my goal, remember, is to get this pattern. So this is where it gets complicated. We're going to take, no, we can't take the 2 out, but I'm going to write sine of 2x, and I'm going to put the 3x beside this. Okay? Do you agree? If this is 1 and this is 1, this fraction is still true. Okay, so again, the goal is to match whatever's here with what the bottom. So what do I put there then? No, whatever's here has to go here. So I got to put a 2x. And you might say, well, how can you just do that? You can't. You got to put a 2x over here to compensate it. That's a form of 1, right? Okay, so I got my form of 1. Everything's all good. What is this equal to when the limit is going to 0? 1. What is this equal to when the limit is going to 0? Well, if I plug it in the way it is, it gets 0 over 0. However, the x's cancel. So what do we get? 2 over 3. And then I still have plus 7/3. So what do I get as my final answer? 9/3, which is 3. What do you think about that? Yes, so now you might have to go back to that one question that was in your homework and look at it again. Okay, if I put 0 in there, I get sine of 0 over sine of 0, which is 0 over 0. Can't do it.
How did you get the sine of 2x over 0?
So now, if I plug 0 in, we get 0 over 0, right? So I need to come up with that sine h over h thing, right? So I'm going to put sine of 2x here. And then, does everybody see this is a divide? Yes? Yes? But I can also put it like this. Yes? Okay. I'm going to put a line here. Okay, good. I like that you agree so much. Okay, now I got to set up whatever's on top to match the bottom. So what do I put on the bottom? A 2x. And I can't just do that. I'm not going to put it here. I'm going to put it right here. Why? I got to put a 5x here. Woo! Yeah. And 5x on the bottom. Oh my gosh. Look at that. Look at that. Look at that. So now, this whole thing when the limit goes to 0 is 1. This whole thing when the limit goes to 1. This, well, if I plug it in, I get 0, 0, but the x's cancel, and I get 2 over 5. 2 over 5, bada bing, bada boom, we're done. Look at that. Okay. Let's move on. I'm glad you're so excited. Okay, so if I plug 0 in, what's tan of 0? What's tan of 0? 0. And I get 0 over 0. Can't do it. So let's change this to sine of 4x over cos of 4x. And then I have this additional 2x at the bottom. Does everybody know what I just did? Nope. I basically split up tan of 4x into sine over cos of 4x, right? Sine of 4x over, do you see this is my tan 4x, and then I just shove the 2x over there because that 2x I want a little bit later. I missed a line. Okay, that's the most important thing, yeah. All right, so I got to get that set up. So what do we got to put at the bottom for it to work? Can't just do that, so I have to put it on the top. Do I need to manipulate this? What's cos and what's on top basically if nothing's there? A 1. So if I put 0 in there, cos of 0 is 1. So what is this equal to? 1. What is this equal to? 1. And what is that equal to? 2. So here's the next identity. Here is the graph of cos x minus 1 over x. Okay, cos x minus 1 over x, this is the graph. What's the limit as x goes to 0? It's intending to go to 0. But if I were to plug 0 in there, what's cos of 0? 1 minus 1, I get what on top? 0. If I plug 0 in there, I get 0 over 0. There's a hole there. But the limit intends to go to 0. So you need to memorize this one now. That cos x minus 1 over x equals 0. So that's another identity. What happens if it's the reciprocal? It's not really the reciprocal though. It's more of, it's not even the conjugate. It's just another form of it. If it's in the form of 1 minus cos x over x, do you see it's kind of like the mirror image, but again, you have a hole right there. So again, here's another one you need to memorize. 1 minus cos x over x equals 0. So again, it doesn't have to be just x. It can be any form there. Do you see? Any form. Right? All right. So we need to memorize that one too. So I highly advise that you get, you know those recipe cards? Cue cards, and start anything you need to memorize, start putting that on a card. And by the end of even 2 months, you're going to have a stack of cards, and you're just going to have to keep on doing it. And so the way I would do it is have this limit here, right? And then on the back side, put 0. And the other one for the sign, I'd put 1 on the other side. So then you have the question and then the answer on the other side. You know what I'm saying? So there's lots of stuff you have to memorize. There is no formula sheet. You have to have everything memorized. There's none. So if I put 0 in right now, what's cos of 0? 1. 1 minus 1 gives me 0 on top. What's sine of 0? 0, and 0 squared is 0. So I get 0 over 0. So I can't do anything. I gotta try something. What can I try? Huh? We can separate them and try to build something. Does everybody know that sine squared x is the same thing as sine x the whole thing squared? Would you agree that's true? Sine squared x is sine x the whole thing squared. So that's what I'm writing there. Okay, so what do I need on the bottom here? An x. I can't just do that. So then I put x on the other side. However, this is not just x on the other side now. I get x squared. So that means I need to put an x squared here, and then that's not going to work. So you go, ah. So then we go, shoot, what do we do? And from now on, I don't want you to erase things. If you get somewhere, it's showing a process. I want to see that process, especially if you're going to ask me questions. I don't want you to erase it. And in an AP exam, all you have to do is go like this to say, don't mark this. Okay? Then in the end, say you still can't get anywhere because you ran out of time. You could erase this, or maybe you should wait to cross it off until you find another solution. But you got to have something down. But they're not going to mark both answers and take, what they'll do is they'll mark both, give a points for there, and you get halfway between the two. Right? So it's not like, you know, you get full marks. Okay, so that didn't get us anywhere, so I'm like, whatever. Okay, let's look at this again. You should know what to do from grade 12 trig identities. I'm giving you a hint here.
Format sheet and save yourself.
I hear conjugate. I hear conjugate. That might work. Okay, we can try that. Do you want to try that? You don't think it's going to work? Oh, what's that? What's that? What's that? Hey, do you hear that? Do you remember that? Sine squared x. Well, say it. You should know this one in and out. Yes? Okay, let's try that one. Limit as x goes to 0 of 1 minus cos x over 1 minus cos squared x. Okay, so now let's plug 0 in there. What do we get? We get 0 over 0 still. So what do we do now? Factor! Right on! Okay, let's factor. Can we factor the top? No, it's already factored. What about the bottom? Oh yeah, we can. What do we get? It's the difference of two squares, right? 1 minus cos x over 1 minus cos x, 1 plus cos x. Yes? Yes? Cancel. Sub her in. What do we get on top? Sub her in. 1 on top, right? Because it all canceled. And what do we get on the bottom? What's 1 plus 1? 2. Two. We sub it in. What do we get? 0 over 0.
Wait, what was the action?
Okay. So we sub it in, we get 0 over 0. Can't do it. So you might say, oh, there's whatever, blah, blah, blah. I do want to show you one technique where we're going to write this as, and hopefully everybody can see that this is the same thing as this. Now look at that and tell me that that's the same thing.
It is the same.
It is the same. It is the same thing, right? This I'm squaring the top, which would put the square there, and I'm squaring the bottom, which would get that. Okay, so now we have a setup happening here. What's missing to make it good? A 3 on the bottom, right? So I'm going to put a 3 on the bottom. Because I can just do that. But I can't just do that. I have to. What do I do here?
9.
I got to put a 9 there. Do you see? I heard somebody gets that there. 3. I actually put a 9 there. Does everybody see I put a 9 there? Not a 3. Because it's squared. So I got to put a 9 there to compensate. You see those cancels. So it's all legit. It's a form of 1. No, the x was already there from the question, right? I don't need to put another x. Does that make sense to you? The x was already there. It's the blue. That's why I'm doing different colors, because this is the stuff I imposed in there. Do you see what I'm saying?
Yeah.
Okay, so what's this equal to when the limit goes to 1? Oh, sorry, when the limit goes to 0. 1. So it's going to be 1 squared times 9, which gives me 9. Wow.